Welcome to our lesson on sets, and this is an introduction to set theory. And our today's objectives to describe and illustrate the following: well-defined sets, elements, cardinality, universal set, null set, subset, and proper subset. To name or write sets using listing method, roster method, rule method, or the set builder notation, and to appreciate the importance of sets. Here are objects, namely wall clock, orchid, orange, table, cabinet, watermelon, hanging lamps, mirror, mango, tansy in a pot, chrysanthemum, and a ball. I want you to create a well-defined group from these objects according to their common characteristics. How many groups are there? Does each object belong to a group? Is there an object that belongs to more than one group? I have created 4 groups from the original set of objects. I have group of fruits, group of flowers, group of spheres, and group of household items. But is there another group that you can think of? Those groups are called sets, for as long as the objects in the group share a common characteristics and thus well-defined. A set is a collection of objects, things or symbols, which are clearly defined. The elements of the set are the individual objects in a set, also called members of the set. The cardinality of the set is the number of elements inside the set. Here are notations that are commonly used in set theory. The capital letters are used to name sets. U is used as universal set, and this is the symbol for the element, not an element. Proper subset, not a proper subset. Subset, not a subset. Superset, union, intersection, number of elements in A or the cardinality. Symbol is N, A, complement, or not in A. This is an empty set or null set. So here I would like to name the set of fruits as set F, and the elements of set F are orange, watermelon, and mango. And its cardinality or cardinality of F is 3 because there are 3 elements inside set F. Can you name the elements of the other 3 sets? And can you give the cardinality of each set? I have an example of set A here, and I can say that set A contain A, B, C, D, and E. So A is an element of set A, B is an element of set A, C is also an element of set A, D is an element of set A, and also E is an element of set A. But if I will be given F, I cannot say that F is an element of set A because I can never find F here. So the notation for that is F is not an element of set A, and all the other letters except the A, B, C, D, and E are not an element of set A. And the cardinality of set A will be written like this. All you need to do is to count all the number of elements. So this is 1, 2, 3, 4, 5. So the cardinality of set A is 5. Do you have any questions at this point? So now let us have this special sets. The universal set. is the set that contains all objects under consideration. Subset is a set of all elements that is part of another larger set. A proper subset is also a subset that is smaller than the complete set. A null set or empty set is a set that does not contain anything or any element. It is also a subset of every set. So now let us have these sets to further explain what subset and proper subset is. So I have here set E contain 1, 2, 3, 4, and 5. Set A contain 1, 2, and 3 as its element. Set B contains 2 and 4. Set C contains 2, 5, and 6. And set D contains also 1, 2, 3, 4, and 5. So I can say that set A set A is a subset of set E, since all elements in A are also found in set E. I can also say that set B is a subset of set E. How about C? Let us check. 2 is 2, 5, and 6 are in set E, but there is no 6 as element here. So we cannot say that C is a subset of E. So C is not a subset of set E. Now let us look at set D. Set D is equal to set E because all elements in D are also found in E. So we can say that D is a subset of E. So now let us have the proper subset. From our definition, a proper subset is a subset that is smaller than the complete set or the parent set. If we are to use E as our parent set, then we can say that A is a proper set of set E because A is smaller. We only have 3 elements here, and these elements are also in E. B also is a proper subset of E. C is not a subset, and C is also not a proper subset. But D, since D is equal to E, and the proper subset definition is it must be smaller than the parent set, so we cannot say that D is a proper subset of E. It can only be subset. So D is not a proper set of E. It can only be subset. So what about the null set or empty set? It says here that a null set is a part of every set. So it can be a subset of those sets. So you can say that empty set is a subset of E, empty set is a subset of A, empty set is a subset of C, empty set is also a subset of D. And I forgot the B. Empty set is also a subset of B. There are different ways of identifying sets. This is an example of written description of set. A set of calendar months starting with J. So we use the listing method. By listing method, we just list the elements. So what are those months starting with J? We have the January, June, and July. So we just list those elements. So I call that set F. And the second method is the set builder notation or the rule method. In set builder notation, we describe sets by stating its properties. So what is the properties of that? Those are the months starting with J. So this is my set. So this is read as set F contains X such that X is a month that starts with J. Let us have another examples of identifying sets. I have here two examples. Number one is M is a set of natural numbers, and by listing those numbers, we have here M. So natural numbers are infinite numbers. So 1, 2, 3, 4, 5, and so on. These three dots here are called ellipses, and it means infinity. I have set n is a set of even numbers. So set n is 2, 4, 6, 8, and so on, because even numbers are numbers that are divisible by 2. So that is 2, 4, 6, 8, etc. And m by rule method, writing it by rule method, I have here m contains x such that x is an element of, this is a natural number symbol. So I have here a box of notation of set of numbers. I have here real numbers, q as rational numbers, q prime as irrational numbers, z as integers, and as natural numbers. I also must have here a w for whole numbers. Okay, so let's have here another. N is a set containing x such that x is an even number. So this element as natural number, this is the property of M, specific property of M. And this is the specific property of set N, because set N is an even number. So we write like this one by rule method. So why are sets important? Because sets are the fundamental property of mathematics. We apply sets in different situations, so they become the powerful building block of mathematics. Do you have any questions? Please do these exercises. Please do the following. List 3 things you learned today, 2 things you'd like to learn more about, 1 question you still have about our lesson, what mathematical terms do you clearly understand, and what other mathematical terms that you have difficulty understanding.